Again a very warm welcome to my dear student of class 10. Now we will start the second topic of the first chapter, that is couple. So what do you mean by couple, student? A pair of equal and opposite forces acting on a body along two different line of action. So here you have to focus the word opposite forces. Student, opposite forces means in the couple two forces are acting, but thing is that their magnitude is same. Means suppose if two forces having 10 Newton magnitude, but the direction of these two forces will be different. Okay. Now we will focus the effect of couple. What is the effect acting on your body due to the couple? What happened? Let us check it. If a couple is acting on the body, student, the first thing you will see a turning effect. Means there will be a turning effect, but no resultant force act on a body. Means there is no force acting on the body. Means sum of the force of the two forces will be 0. Why you know? See, here what I have written. Opposite forces means suppose one force having 10 Newton, another is 10 Newton, but two are of different direction. Means one is plus 10 Newton, another is minus 10 Newton. And if you add both the term, what happened? The resultant is 0. Understood? Okay. Now come to the second point. It cannot produce translational motion. Means whenever couple act on a body, is never move in a straight line. Means body will turn. Clear? Now couple, let me explain the couple with the help of a diagram. See the diagram. This is a rigid body, student. This is a rigid body. What we have done it, I have taken one point of rotation and I have considered 2 points. This is point 1 and this is point 2. At both the points, student, what I have done, I have applied one force. This is one force and this is another force. Are you seeing something? This is also I have written force F, student, and this is I have written force F. Means what? Means the magnitude of two forces will be remain same. But can you see the direction? This force moving this side and this is moving this side. So the direction of the force are different. So once you are writing the formula for the movement or the torque of, or you can say couple, okay, in the short called couple, that is tau. Now check it out. Last video also I have taken tau. This video also I have symbol taking tau. So there is no restriction of taking same symbol, but yes, this tau is the moment of couple, that tau is for the torque. Okay. Now check it out. So this is the force F and this is distance OA. So first part I can write F into OA plus F into OB. And if you know, or I have told you that two forces magnitude is same. So I have taken F common. OA plus OB, that is nothing but AB. Understood? The formula is F into AB. So what AB represent, that is most important. Here student, AB stand for the perpendiculars between two forces. Have you remembered the concept of torque? That is, we have written one force, but here the distance between two forces. Clear? Now, some important point you have to remember for the couple. What is that? The couple is independent of the point of rotation. Means couple does not depend upon the point of rotation. Clear? Okay. Now we will move to the next topic, that is equilibrium of the body. So what do you mean by equilibrium? See, when a number of forces acting on the body produce no change, means you are applying the force on the body but body is remain as it is, then it is known as equilibrium of the body. Now, how many types of equilibrium you can able to see? So equilibrium divided into 3 parts. One is stable, second is unstable, and third is neutral. So what do you mean by stable and what do you mean by unstable and neutral? Okay, let me focus first stable. A body is said to be stable equilibrium if it tends to regain its equilibrium position after being slightly displaced and released. But what happened here? The minimum potential energy it will acquire. So whenever a body in a stable form, it acquires minimum potential energy. Now, we will focus on unstable. Means if we get further displaced, we are applying the force, body displaced further, and it's acquire equilibrium position after being displaced and released, that time we can say it is an unstable. Clear? Now unstable example, what is the most important here is it acquire maximum potential energy. So whenever a body in unstable, it acquire maximum potential energy. Now what is neutral? A body staying in equilibrium even after being slightly displaced. Means you are displacing the body but it is remaining equilibrium. And here what happened? The potential energy remain constant. I hope you have understood. Now we will move to the condition of equilibrium. So what are the conditions required to make a body equilibrium? And that 2 points we have to remember. One is the resultant of all the forces acting on the body should be 0. Means you are applying different numbers of forces, but when you are sum of all the forces, what happened? The resultant is coming as 0. Okay. Now second point, the algebraic sum of moment of all the forces acting on the body about the point of rotation should be 0. Means what? Sum of anti-clockwise movement should be equal to sum of clockwise movement. So this second point I can say this is the most important point, student, which you have to remember. And this point is also in the form of principle of moment. Now let me explain the principle of moment. What I have told you, see, it based on the second point. What is that? The sum of anti-clockwise movement is equal to sum of clockwise movement. And I can explain this concept principles of movement by the help of one diagram. See, I have considered 1 meter scale. You can give a number. I have not done it. Let me, in a very simple manner, I have drawn this one. I have hanged this metal meter scale with a thread, and what I have done it, here I have hanged one weight this side and another is this side. So you can adjust this weight, student, because this is as it is hanged with the thread. You can move this side, you can move this side. So what is the different thing what you can observe is, see, this one, student, is moving like this. Means this side you can move, this side, okay, you can move this weight like this in this direction, and this is this direction, means this is away, this is towards, okay. And see the distance, this distance I have taken L2 and this distance I have taken L1. This is from the point of rotation. Now if I will focus on the formula, what is written? The sum of the anti-clockwise movement is equal to sum of clockwise movement. So this I have taken as anti-clockwise, this I have taken as clockwise. So you write the formula very easy, that is anti-clockwise W2 into L2, here W1 into L1. Now you combine as a principle of movement, the sum of that is anti-clockwise is equal to clockwise. So this is the formula what you are getting as a principle of movement. On basis on the principle of movement, student, we will focus 2 questions I have given you as a homework. A uniform meter rule weight 10 GF is pivoted at its 0 mark. This is a 0 mark. What is the moment of force depress the roots, and how you can be made horizontal by applying the least force, okay. Second question, a uniform meter scale can be balanced at 0.70.0 centimeter mark when a mass is 0.05 kg is hanged from 94.0 centimeter mark. First part is draw a diagram of the arrangement. Second is find the mass of the meter scale. If you have any doubt in this problem, I can solve afterward, but first you try, okay. Now I will move to the concept of center of gravity. Okay, what do you mean by center of gravity? Let us check it out. The point about which the algebraic sum of the moment of weight of all the particles constituting body will be 0. Means the point where you have to consider where the algebraic moment or the weight, means W1 plus W2 plus W3, all if you will add, the net resultant will be 0. Okay. So some important point again you have to remember for the center of gravity. What is that, student? Check it out. The position of the center of gravity of a body of a given mass depend on the shape. Means suppose this is a wire. I have taken one wire and with the wire I have make a circular. So this, the center of gravity is different, and if it is a square, student, the center of gravity is different. Now second point. It is not necessary that the center of gravity always be within the material of the body. Means center of gravity is the point where you can balance the body, student. Okay, so the point where you can balance the body, that is the center of gravity. Suppose this is an hollow ring, and in ring you know there is nothing material is present. So what happened? The center of gravity, we know that it is present at the center, means there is no material present, but then also the center of gravity present at the center. So this satisfies the concept that it always be within the it is not necessary that the center of gravity always within the material of the body. Maybe material outside where there is no presence of material. Okay. Now some work I have to give it to you from your book, that at least you remember this concept, student, that different object and the position of gravity. This much you can remember, and this will be helpful to you in future also. When you will go to the higher classes in the 11 and that part, this concept will be help you a lot. So at least you remember this concept, the what is the object and where is the position of center of gravity. Okay. Now I will move to the last topic of this chapter, that is uniform circular motion. What do you mean by that? When a particle move with a constant weight. So this word is very much important, student, constant weight. So when a particle move with a constant speed in a circular path, so that is known as uniform circular motion. Means you can take a very simple example. You hold one stone, very small stone, not a bricks, it should be stone. Okay, and tie it with a thread and rotate it in a horizontal. You will see a very circular path can be created by the stone, and that is a simplest example of uniform circular motion. Now some basic concept you have to remember for uniform circular motion. What is that? Uniform circular motion, the particle velocity varies. Means here particle, see, this is the word constant speed, but what can be changes? The velocities can be varies. So this is a most important point which you have to remember. Speed is constant but velocity varies. Second thing is what? Here accelerated motion with a constant rate, means acceleration is present in the presence of constant speed. Okay. Now last is the topic, force acting on the circular motion. What is that? Two forces are basically acting on the circular motion, student. One is the centripetal, another is centrifugal force. Centripetal force we can observe, that's why it is taken as a real force. But centrifugal force we cannot see and cannot be explained clearly. So that's why it is named other as virtual force, or you can say imaginary force, which cannot be seen. Clear? Now how you can identify? If I can say both are acting together, so centripetal force always toward the center, means whenever a body is rotating or moving, that anything which is moving towards the center, that is a part of centripetal force. And if the things force which is taking body away from the center, that is a centrifugal force. I hope so you have understood the concept of the first chapter and read it clearly and carefully. God bless you. Thank you so much for watching this video.